welcome back to your favorite pre-calculus 1 expanded. We're going to take a look at some operations with square roots. This time we're going to do some adding and subtracting. And if you remember before when we were doing it with just variables, numbers, terms, we had to have the same variable. Both of these have an x, and they have to have the same degree to be like terms to add them, right? So 7x plus 6x is 13x. Well, it's the and I should expand that a little further, like 3a squared plus 2a, we cannot combine those. Those are not like terms because one has a degree of 2, the other one is just a first degree, so we just leave it right there. Well, with radicals, they have to have the same index or root, and they have to have the same radicand, so the number underneath the radical, to be like radicals. That's the requirement. So for example, here I'm showing 7 square root of 11 plus 6 square root of 11. There's 13 of those square root 11s. Right? The first example, 9 root 7 minus 6 root 7. Again, I check, are they both square roots? Yeah, they're both square roots. Do they both have the same thing underneath the square root? Yeah, they both have a 7 underneath the square root. So we can go ahead and add or subtract them. So 9 of those bananas minus 6 of those bananas is 3 bananas, right? 3 of those root 7s. So you could pause that next one. Again, you're checking, are they both square roots? Yes, they both have the same radicand. In other words, the number underneath the radical. Yes, they do. So 2 plus 7 is 9 of those square root of 3s. Now, sometimes they're not simplified, which is kind of annoying, but you can deal with that. You know the square root of 45, that's 9 and 5, and the square root of 9, that's 3 and 3. So just go ahead and simplify it first. So you've got a root 5 plus a 3 root 5. They are like radicals. They're both root 5s there. So I have one of these root 5s, if there's no number in front, it is a 1. So I have 1 root 5 plus 3 root 5 is 4 of those root 5s. Similarly for the 75 here and the 27, we're going to have to simplify those. So we know 75 goes into, let's see, that's 25 and 3. So 5 and 5 and 3. We know the 27 is 9 and 3. Here's our 9 and another 3. So we've got square root of 25 is 5. Square root of 9 is a 3. And they are like radicals. They're both square root of 3s. So 5 root 3 plus 3 root 3 is 8 of those root 3s. Go ahead and try those next two. Pause the video. Should get a 1 root 5 on that once you simplify this down. Similarly for the square root of 75 here. 75, we've got a 25 times 3. 25 is 5 and 5. 28, I got 7 and 4. 4 is 2 and 2. So it looks like I got a 5 coming out. So I could get a 2 coming out. So I got 10 root 3 minus 6 root 7. Let's do some more here after that one. So we put that 45 up. We got 9 and 5. So 3 and 3 and 5. The 6 I can't do anything. That's just 2 and 3. The 20 I can. 4 and 5. So here's my 4. 5. So it looks like a 3 comes out and multiplied by the 9. So I got 27 root 5. Minus 2 root 6. A 2 comes out. 8 times 2 is 16 root 5. So my only like radicals would be the 27 and the 16. So that would be what? 43 root 5 minus 2 root 6. So there's our final solution. You can go ahead and pause it for that next one and check yourself. Check yourself on that one. You should just have a couple like radicals to combine. 12 root 3 is what you end up with, minus 6 root 5. And let's do some third root now and see if we get some like radicals on this. So I'm thinking on this next one, I've got a 24. Oops, wrote that wrong. 4 times the third root of 24. So 24 is 8 and 3. 8 is 2, 2, 2. Minus 7, I got third root of 81. Well, 81 is 9 and 9. 9 is 3 and 3. I'm looking for 3 of a kind. So a 2 comes out. I'm left with a third root of 3 on this one. A 3 comes out. I'm left with a 3 underneath as well. So I got 8 times the third root of 3 minus 21 times the third root of 3, which, let's see, 81, or I'm sorry, 8 minus 21, they are like radicals, would be negative 13. Third root of 3. Right. 8 minus 21, because they're both third root of 3s. Go ahead, pause it, try that next one. We'll end up with that negative third root of 2 on that one. I'm going to multiply square roots to finish out this CR14. So we're going to be multiplying, we're going to distribute that. Square root of 7 times the square root of 14 plus square root of 7 times a negative root 7. Well, positive times a negative is a negative. So I've got square root of 7 times 14. I can put those all underneath the same radical. And then we're just going to simplify that. 14 is 7 times 2. Here I'm taking a square root, so I'm just looking for 2 of a kind. So it looks like we have 7 root 2 minus 7. Now we're going to go ahead FOIL. So let's just go first. Square root of 6 times square root of 6. That's our first. Then we're going to go our outer. So we got square root of 6 times square root of 8. And we're going to do our inner minus square root of 8 times square root of 6. That's our inner. Then our last. Negative times a positive is a negative. Root 8 times a root 8. Outer, inner, and last here at the end. Well, square root of 6 times square root of 6 is 6. Here I've got a square root of 48 minus a square root of 48 minus an 8. Well, those are gone, so I'm just left with 6 minus 8 gives us a negative 2. Go ahead, pause the video and try that next one. Should end up with a 6. If you want to pause that video, take a look at the work there. Notice the inner terms are like terms. 19 times 13 is the same as 13 times 19. So one's positive, one's negative, so they're going to cancel there. Let's go ahead and keep foiling a few more of these. So we've got 5 times 2, I got 10. 5 times root 5 is 5 root 5. The inner term is negative root 5 times 2, so minus 2 root 5. And then the last one, negative root 5 times a positive root 5, is just a negative 5. Notice these are like terms. 5 root 5 minus 2 root 5 is 3 of those root 5s. 10 minus 5 just gives us a 5. So I got 5 plus a 3 root 5. Let's do another one here. 4 times 3, I got 12. 4 times that root 2 is a 4 root 2. Root 7 times 3 is a 3 root 7. And finally, root 7 times root 2 is root 14, which I can't do anything with that. That's just 7 and 2. Can't simplify that. And then I take a look at this and I say, well, is there any like radicals, like terms? No, there's nothing I can do with this. So I'm actually stuck right there. So that's our final answer on that one. Why don't you go ahead and try that one. So you end up with a 46 plus a 2 root 2 on that one. Now we're going to go ahead and we're going to rationalize denominators to make them more proper. We don't want, square root of 19 is an irrational number. In other words, in decimal form, it does not terminate or repeat any pattern or anything. So it doesn't simplify nicely, right? It's just stuck at that square root of 19. We don't like those irrational numbers in our denominator, so we rationalize them. So what we do is we multiply it by itself. So if I multiply the bottom by the square root of 19, I got to multiply the top by the square root of 19, right? Because square root of 19 over square root of 19 is 1, right? I'm just multiplying this by 1. Like 7 times 1 is still 7. So I'm not changing this. I'm just changing what it looks like. So I got 1 times the square root of 19 is square root of 19. And then I got square root of 19 times square root of 19, which is just a 19 on that. And that's how you're going to rationalize those. Here you've got a square root of 6. Again, there's nothing I can do. It's not like I can simplify that square root of 6 anymore. So I'm going to go ahead and rationalize that. And so this becomes negative 42 root 6 over 5. And then we got root 6 times root 6 is just a plain old 6. But 42 goes into 6, right? In fact, let's write it as negative 7 times 6. See how the 6's cancel, right? 42 over 6 is 7. So we got negative 7 root 6 all over 5 on that. That's how you're going to rationalize it. The singular irrational number in the denominator. Let's go to the next one where you try that. Should end up with 3 root 7 over 4 on that. Now, if you look at this next example, notice not only do I have a square root of 17, I got two terms there. I got square root of 17 plus 12. And so the trick on this is to go ahead and multiply by the conjugate. The conjugate of square root of 17 plus 12 is the same terms, but instead of a plus in the middle, you change it to a minus. The conjugate, just change that middle sign. And if I multiply the bottom by the square root of 17 plus 12, I got to do to minus 12. I got to do to the top too, right? So I've got 8 root, and I'm going to distribute that. 8 root 17 minus 8 times 12. What's that? 96. And then on the bottom, I'm going to FOIL. So square root of 17 times square root of 17, that's 17. And then the outer is a minus 12 root 17. The inner is a positive 12 root 17. And then the last 12 times negative 12 is just a minus 144. Notice those are like terms that cancel. So I'm just left with 17 minus 144 on the bottom. Top I have 8 root 17 minus 96. That's over 17 minus 144, negative 127. And then I don't really want that negative in the denominator, right? We don't want to write it as 1 over negative 3. We would write it as negative 1 over 3 would be preferable. And so let's go ahead and take that negative up top. So that would go to both terms. Or you can write that as 96 minus 8 root 17 all over 127. So you could do the same with those two. Go ahead and practice rationalizing those. It should end up with 5 root 6 plus square root of 102 all over 8. And then your last one there, you can go ahead and pause as well. You'll get negative 28 minus 4 root 6 all over 42. Thanks so much for watching. I'll see you next time.